Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to talk about how to solve cosine equations with multiple solutions if the period has changed. All right, if you either compress it or stretch it out, either way. So let's check it out. Let's go for it. We're going to be solving four equations here, and remember, this is a video, and use it properly, right? Go at your own pace. Pause, play, rewind, and go slow because taking notes does not help you at all if you don't understand it. So go slow. All right, so let's zoom in here. Let's take a look at the first one here. Oh, let me say this. If you're watching this video, then obviously you're a student of mine and you're in Canvas. So go to Canvas here. All right, go to this right through here, which you probably already did because that's how you got this, right? And then click on the hyperlink for the student copy, upload it to your OneNote, and then get started. And then go for it, right? Okay, now if you are doing this first, then obviously check your solutions here because the quality of your work is more important than anything else. Doing is one thing, but doing it right is another thing. All right, so here we go. I'm going to solve this equation. 2 cosine x minus 1 equals 0 from 0 to 2 pi. All right, we're going to solve all of the equations here from 0 to 2 pi, which limits the solutions because otherwise these have an infinite number of solutions that you guys know. All right, I'm going to add one. So I get 2 cosine x is equal to 1. I'm going to divide by 2. So I get cosine x equals 1/2. And as you guys know, looking at the 30, 60, 90 here, cosine of 60 degrees or pi thirds is 1/2. All right, cosine of pi thirds, which is 60 degrees, is equal to 1/2. Looking at the little thing, a triangle here, or you can use the unit circle, I suppose. But this is how I developed it back, about, I don't know, about a month or two ago. All right, and this is how we do it in geometry too. Basic, simple mathematics. The sine of, or cosine of 60 degrees is adjacent divided by hypotenuse, and there you go, 1/2. Well, cosine is positive in quadrants 1 and 4. Okay, so what we're going to do is we're going to say, okay, quadrant 1 angle, x is equal to the inverse cosine of 1/2, which is pi thirds, right? It's restricted. So remember that. But this is an equation, so you have to find all solutions. And cosine's positive and also quadrant 4. Okay, so you got another one here. So quadrant 1, quadrant 4. So quadrant 4, well, how do you get that? Well, you take 2 pi minus pi thirds, right, which is 5 pi thirds. And there's your quadrant 4 angle. Okay, and then again, if you wanted to go verify everything I say, go into Desmos here. All right, go ahead and you got to adjust the use a wrench in the upper right, adjust it with a proper scale. I talk about that in class, and then what you want to do is let y equal to 1/2 because the second function is 1/2, and then of course you want to just click on the intersection points, and there you go, pi thirds and 5 pi thirds. Okay, right there. So the 1/2, the horizontal line at 1/2 intersects it at 5 pi thirds and 5 pi thirds in quadrants 1 and 4. Quadrant 4 is between 3 pi halves and 2 pi, and quadrant 1 is between 0 and pi halves. All right, and if you are, I do this all the time in class, right through here when you're working on this video here. Let me see if we can just paste it in. We're digital in this class, so you can always do this right through here and then paste this into your lesson through here. Again, this is cosine x is equal to 1/2. And you know what? I didn't get I'm going to redo that because I didn't get the right screenshot. So apologize. Let me get the right screenshot. So let me bring up Desmos again. Here we go. So when you're on an iPad like I am and you guys are, you have to know how to screenshot. There we go. And then you copy, you paste it in. All right, and then you're good to go. So let me paste that back in. There we go. So I'm just illustrating what you guys should be doing when you're checking work at home when you're not with me. And notice here that the cosine function here when cosine is equal to 1/2, right through here at pi thirds. So this is cosine x is equal to 1/2 at pi thirds and at 5 pi thirds. Just take a look at the solutions right here. Okay, the angles. There you go. And again, this is in quadrant 1 between 0 and pi halves, and between 3/2 pi and 2 pi. Guess what? You're in quadrant 4. And that's why you're looking for two solutions. Okay, that's the first one. Now let's go to the second one. Here we go. Now when you change the period, you got different number of solutions here. So b is 3 here, and when b is 3, you get 2 pi thirds, and this is a compression. And when you have a compression, you have more solutions, right? And so as you guys know, it's a compression, so we have 3 times as many solutions. So 3 times as many solutions here, so it's going to be 6 solutions. We're going to look for them. Okay, I've talked about that in class, and now let's do it. All right, so here we go. So we're going to add 1 first, and then divide by 2. So we have cosine of 3x. When you add 1 and divide by 2, you get cosine of 3x equals, well, guess what? You get you get cosine of 3x equals 1/2. Now, we want to focus in on proper mathematics and how you write it here. So we're going to take the inverse cosine. So not x, but 3x now. The angle right here. Notice the angle. That's an angle. Is equal to 3x, not x. And that's equal to the inverse cosine of 1/2. And guess what? That's positive, right? And again, because it's positive, guess we have 2 solutions, right? Just like we just talked about. All right, so we're going to separate this into 2 equations. So, excuse me, not cosine. So 3x here is going to be equal to our first solution in quadrant 1, which is, you guys know, is pi thirds plus multiples of the period, 2 and pi. So again, this is our quadrant 1 initial angle. And then, when is 3x is equal to the other angle in quadrant 4, and we already discussed that, so it's 5 pi thirds plus multiples of the period, which is 2 and pi. Now remember, to get from quadrant 1 to quadrant 4, like from here to here, all you do is to take 2 pi minus pi thirds, which is 5 pi thirds. That's your method. All right, you should know that. Okay, so now what we want to do is solve for x, because these are the initial angles, but they're not the solution. So we want to divide by 3, either divide by 3 or multiply by a third, however you want to think about it. A third of a third is a ninth, so x is equal to pi ninths, all right, plus 2 in pi, so 2 in pi thirds. So there's your new period. So remember, your period here is 2/3 pi. So we have, let me write a period here. You have to add multiples of the period to get more solutions. So what do we have? Well, our first solution is pi thirds. And then if you add, let me see, our denominator is 3, so we add 2/3. Actually, excuse me. I didn't say that right. Let me back up. A third of a third is a ninth. I didn't write down the right answer, sorry. Okay, so I get pi ninths. Pi thirds divided by 3, or 1/3 times a third is pi ninths. Sorry. Let me fix this. So I get pi ninths, and then what I have to do is add multiples of the period, which is plus 2 pi thirds, or I can say, if I multiply by 3, I get 6 pi ninths. Okay, so I have to add 6 pi to the numerator. So 6 plus 1 is 7, so 7 pi ninths. Keep adding the period. 7 and 6 is 13, so 13 pi ninths. And then if you add it again, if you add 6 to it, you get 19 pi ninths. But 19 divided by 9 is over 2. Okay, so what we're going to do is we're going to just cross this out. All right, this is out of the domain. This is greater than or equal to 2 pi. Okay, out of the domain, which is from 0 to 2 pi. Because again, we're trying to solve for all solutions between 0 and 2 pi. Okay, so on the domain from 0 to 2 pi. Okay. All right. So now what do we have? We have to solve for the other ones, right? So we're going to have to multiply by a third again. Okay, time by a third. 5/3 pi times a third is 5 pi ninths. So x is equal to 5 pi ninths plus 2n pi thirds, because you got to divide everything by 3, right? A third of a third is a ninth. Okay, so now, so what are all my solutions? My first one is 5 pi ninths, and then I got to add 6 ninths to that, so I get 11 pi ninths. Add 6 to 11, get 17 pi ninths. There's my last one there. If I do it again, it's a solution, but it's out of the domain. So if I add 6 to 17, I get 23 pi ninths. Oops, sorry, 23 pi ninths. But I'm going to just cross this up because, again, it's greater than 2 pi right here. So I get 6 solutions only, okay, on the interval from 0 to 2 pi. There's an infinite number of solutions here, as you guys know, all right? But if you think about it here, there's only 6 within the interval. So how do you know that? Well, let's check it. All right, so let's enter this. You know what? Let's just go full screen. Okay, so what you want to do is type the functions in. All right, so here's cosine of 3 pi. Here's 1/2, and then so you just type them in, and then you start clicking on the intersection points. Okay, this is your first one, second one, third one, fourth one, fifth one, and sixth one. There you go. And there are all of your solutions of this equation. All right, and notice they're all on ninths. So now let's take this and let's bring it into our lesson, okay? So just copy it and then paste it into your OneNote. Okay, this is the stuff that I do in class. All right, and this right here validates everything I just said. Okay, because now you can see that we have cosine of 3x here. Look at the function here. Look at the system. Is equal to 1/2. Well, it's at pi ninths, 5 pi ninths, 7 pi ninths, 11 pi ninths, 13 pi ninths, 17 pi ninths. So there you go. We have 1, 2, 3, 4, 5, 6. 6 solutions. Okay, so this validates everything I just said to you. So, okay, there you go. And that's what you want to do at home. You want to practice in such a way that you understand things, right? And you want to validate things. You want to check things. And there you go. All right, there's number 2. Now let's take a look at number 3. So here, solve cosine of 4x equals root 3 over 2. All right, so here we go. We got to take the inverse cosine, right? Okay, dokie. All right, so now here, what do we do? So now b is 4. So that's going to be, let me see. So if b is 4, p is 2 pi, whoops, 2 pi divided by 4, that's pi halves. So it's a compression. All right, so we're going to have 8 solutions here. All right, 4 times 2 is 8. We're going to have 4 times as many solutions because this thing oscillates 4 times from 0 to 2 pi. And if you don't see it, well, graph it. You'll see it. Okay, so the first thing we do is we take the inverse cosine. So now we do that. So 4x is equal to the inverse cosine of rad 3 over 2. And again, we're dealing with the 30, 60, 90 triangle, so let's draw one. So 30, 60, 90, 2, 1, rad 3. And here we know, look at this, just by looking at this little triangle, we know that the cosine of pi 6, so cosine of pi 6 is equal to rad 3 over 2. All right, this is from SOHCAHTOA. SOHCAHTOA, right? Adjacent divided by hypotenuse. So the cosine of 30 degrees, which is rad 6, excuse me, pi over 6, is equal to rad 3 over 2. All right, so that's a reference angle. But this is positive, as you guys know. This is positive, and we're dealing with quadrants 1 and 4. Cosine's positive there. So let's separate, and we have 2 equations here. So I need to solve when is 4x equal to pi 6. All right, that's your quadrant 1 angle. All right, and on the quadrant 4 angle, well, when is 4x is equal to that? Well, to get from quadrant 1 to 4, let's put your method is 2 pi divided by the reference angle, which is pi 6, and 2 pi minus pi 6 is 11 pi 6. All right, so I have 11 pi 6 plus multiples of the period, 2n pi. So I'm going to add multiples of the reference angle, add multiples of the period to get all the solutions. Okay, now what we want to do is we want to solve for x. So I either divide by 4 or multiply by a fourth. I'm dealing with fractions here, so I think multiplying by a fourth would be easier. So here, a fourth of a 6 is, guess what? It's 1/24. So here, pi 24ths, and now you got to take 2n pi divided by 4. So 2n pi divided by 4 is n pi halves. Guess what? That's your period, okay? I just talked about that initially. This is your period, pi halves. So to get more solutions, we add the period. All right, we'll do that in here in a minute. So now here on the next one here, we got to take the fourth of 11 pi 6, which is 11 pi 24ths plus n pi halves, which is your period again. Again, this is just multiples of the period, which you guys got to get used to. And then what are your solutions? Well, we're looking for 4 on the first one, 4 on the next one. Okay, so we have pi 24ths. What's the next one? We got to add pi halves. Now, pi halves and 24ths, if you just multiply both by 12, you get 12 pi 24ths. So all you have to do is add 12 to the numerator. So you get 13 pi 24ths, add 12 to 13, 25 pi 24ths. Oops, sorry. And then add 12 again to 25. 12 and 25 is 37 pi 24ths. And they're the first 4 solutions. Okay, now we got to get the other 4. So now what are the other 4? So we have here, we have 11 pi 24ths. Again, you have to add the period, which is 12 pi 24ths, right? Which is just simply pi halves. I have fractions here, so you have to have common denominators. So add 12 to the numerator. 11 and 12 is 23, so 23 24ths. 23 plus 12 is 35, so 35 pi 24ths. 35 and 12, 47 pi 24ths. And there you go. There's 8 solutions there. So 8 solutions in all. Okay. So now how do you know that? Well, or how do you check that? Well, let's go to Desmos again. Here we go again. This is what I always do. And all you do is type in your function. So when you type in your function, let's type in, I already typed this in because I've already done this before. So you have to let y equal cosine of 4x, and then let y equal root 3 over 2. So there we go. I'm going to go full screen so we can see this better. There we go. So y, there we go. So now we can see a little bit better. Okay, so now you adjust your screen so that you can see things better. Okay, so there's your first one, second one, third one, fourth one, fifth one, sixth one, seventh one, and eighth one. There we go. There's all of them. Screenshot it, bring it to your OneNote. Okay, we do this all the time. Get good at it. You got to learn how to use your technology. All right, there we go. So I'm going to bring this one in. Click on text box or text mode with that T on your iPad and just press paste. And there you go. There's your graph. And this right here is the graph of your equation. Cosine of 4x is equal to root 3 over 2. Oh, I put in the wrong spot. Okay, so let me do that. Let me change that because it's in the way of my next one. It's okay. We're using digital technology here. You can move things around, right? So no problem there. So let's just bring this over here. There we go. All right. And there is the graph of all of these solutions right through here. Look at that. That's pretty cool. Okay, so here I have cosine of 4x is equal to rad 3 over 2. And again, the solutions are all of these intersection points in red that I'm highlighting here. There's 8 of them. All right, 8 solutions. You just have to look. Okay, and there's your system right here. Pretty cool. Pretty cool that you can check everything with decimals. Okay, last one. All right, what happens when you change b to 1/3? What happens to the period? It's not a compression, it's an expansion or a stretch. So here we go. B is 1/3. That means the period is 2 pi divided by 1/3, which is 6 pi. So it's a stretch. Okay, so this is going to affect the solutions. We're not going to increase the solutions here. All right, so what do we have? Well, let's start taking the inverse, right? Because that's what we're doing. We talked about how to take an inverse. So 1/3 x is equal to the inverse cosine of rad 2 over 2. And we want to find all solutions from 0 to 2 pi. Well, rad 2 over 2 exists on the 45, 45, 90, which is a isosceles triangle. Okay, so we have rad 2 here. Let me write that better. Okay, so rad 2 on the hypotenuse, 1, 1. And we know that the cosine of pi fourths, which is 45 degrees, is rad 2 over 2. Okay, 1 over rad 2 is the same as rad 2 over 2. So we know that. Now, this is a positive number, and cosine is positive 1 and 4, so we're going to have two different situations. So here I need to solve when is 1/3 x is equal to pi fourths, which is your quadrant 1 angle. All right, when is 1/3 x equal to the quadrant 4 angle? All right, cosine is positive in quadrant 1 and quadrant 4. Whoops, 4. All right, how do you get from 1 to 4? Well, you take 2 pi minus pi fourths, and you get 7 pi fourths. There's your quadrant 4. All right, now, of course, you have to add multiples of the period, so I'm going to add 2 and pi to both. All right, now we got to solve for x, right? Well, how do you do that? Well, you just simply multiply by 3. So I get 3 pi fourths plus 6 n pi, right? 3 times 2 is 6. And then here I get 3 times 7 pi fourths, which would be 21 pi fourths plus 6 n pi. All right. So now you got to think, what were all the solutions? Well, let me see. We have one solution here. We have 3/4 pi. And then here, this is 4 divides into 21, 5, remainder 1, so 5 and 1/4 pi. This is greater than 2 pi, so it's out of the domain. What is the domain? It's from 0 to 2 pi, okay? So we're not going to consider this a solution. All right, and that's all there is to it. Well, with except checking, so let's check it. All right, so now notice I'm not deleting any of the functions here, so I'm just typing them in and then trying to, and I saved them, adjust the period here. I need to see everything from 0 to 2 pi. Okay, so there we go, 0 to 2 pi. And notice there's only one solution from 0 to 2 pi. So it's right here at 3/4 pi, all right, which is what we solved for. So let's go ahead and bring this into our lesson here. This is what you guys should be doing if you're actually listening and participating. There we go. All right, copy it, bring it into your OneNote, paste it in, right, like right below it or right next to it, because I can see everything that you guys submit, right? So there we go. And then if you notice here, look at our system here, cosine of 1/3 x is equal to 1/2 right here, right? There's your angle, right? 3/4 pi from 0 to 2 pi. So this is the domain. Okay, that's a full-blown lesson right there. That's a lot. Okay, so if you want to study well, do something like this, because if you can produce a mind map like this and back all your work up with Desmos and make sure you're doing it correctly, oh my God, you've learned something. So do your best. All right. Practice all the different variations of anything. And then when it comes to the test, it doesn't matter what I give you guys. You're going to be able to do well because you've practiced properly. Okay. And this is Mr. Ainsworth here at Gray Oak High School in Temecula, California in the year 2025. I'll see you guys soon, hopefully in class. Take care. Bye-bye.